Okay. So far we have seen functions with a single formula. Sometimes what happens is the formula of the function changes depending on the location. That kind of function we sometimes call piecewise function. Let me write down one example of piecewise function and I will explain why I said something like before. Suppose f of x equal to x square plus 2 if x is, let us say, bigger than 1, and let us say f of x equal to x only if x is less than or equal to 1. If we look at this formula, what this formula is telling is for any x which is bigger than 1, f of x is x square plus 2. However, if x is less than 1, then the formula of the function is x itself. So, the formula of the function is different depending on what is the value of x. This kind of function is called piecewise defined function. There is a definition below 1 and there is another definition above 1. So, if we are thinking of the graph paper, graphing this function in a paper, so if this is 1, there is some formula if x is less than 1. There is one formula here, basically x, and there is another formula if x is more than 1, basically x square plus 2. So, on this piece of the domain, the formula is x, and on this piece of the domain the formula is x square plus 2. Basically the formula changes depending on the location. X is location, x square plus 2 or x is the formula. If the formula changes depending on the location, we call them piecewise function. So, this is an example of piecewise function. Well, now the next thing we want to do is graph the piecewise function. So, in order to graph this piecewise function, let us see. Basically what we have to do in order to graph this piecewise function, basically what we have to do is graph each piece separately. So, this is one. According to this definition, according to this formula, after x equal to, if x is less than 1, below x equal to 1, the formula of the function is x. So, basically below x equal to 1, I have to be graphing f of x equal to x. This is the graph of f of x equal to x. We know how to graph a single function. Below x equal to 1, graph f of x equal to x, and above x equal to 1, oh sorry, this is not the graph of x equal to f of x equal to x. So, below x equal to 1, graph f of x equal to x. F of x equal to x means when x equal to 1, y should be 1 also. So, the graph of f of x equal to x should look like this, f of x equal to x. Now, as soon as we reach 1 and we go further down, we have to be using this formula. In this region, the graph is, the function is x square plus 2. So, if I think of x equal to 1, I should start from 3. So, this is 1, let us say this is 2 and this is 3. So, I should start from here and 3, and if x equal to, let us say I choose x equal to 2, 4 plus 2 is 6. So, I will get a point here. So, in this region the graph will be something like this. So, this is basically the graph of the function, meaning that if we want to graph a piecewise function, graph the corresponding function in the corresponding pieces. Another thing we need to know is how to evaluate. Now evaluating means, now suppose for the same function, suppose we want to find how much is, for example, f of minus 5. So for the given function, how much is f of minus 5? If I want to find f of minus 5, the first thing I need to answer, or I need to ask myself is minus 5 bigger than 1 or minus 5 less than 1? Of course, minus 5 is less than 1. So the second formula, basically f of x equal to x, should be applied. So this is given by negative 5 itself, because minus 5 is less than 1. So f of x should be equal to x itself. F of minus 5 should be equal to minus 5 itself. Now let us say I want to evaluate f of 2. Again I should be asking the same question, if 2 is bigger than 1 or 2 is smaller than 1. Of course 2 is bigger than 1. So in order to evaluate f of 2, I should be using this formula x square plus 2. So if I use x square plus 2, f of 2 will be equal to 2 square plus 2, 2 square is 4 plus 2, this is equal to 6. So I would say again, because 2 is bigger than 1. Sometimes we may have to find f of 2 plus f of minus 5. If we know f of 2 and we know f of minus 5, it's just about replacing the corresponding number. F of 2 is 6, f of minus 5 is minus 5, so this is 1, simple. Sometimes we may have to find f of 2 times f of minus 5. This is also same, f of 2 is 6, f of minus 5 is negative 5, 6 minus negative 5, negative 30, we are done. So basically we can graph a piecewise function, we can graph piecewise function, and we can evaluate piecewise function. Okay, good.